Okay, so this is Team 3's NASA Mars landing final report for our first year engineering lab, Section 8 class. So this is a basic overview of what our presentation will talk about today. First, we'll go over introductions, give background on this project and the requirements from our contractor. Then we'll go over final design, our manufacturing activity, and give test results and a conclusion about our project. First, here's our team members. Our team is team number 3, and we're Engineering Incorporated. Will Binkley will be our verification and test manager. I myself, Faith Alessandra, will be our project manager. Tyler Leroy will be our construction manager. And Xavier Jones, although he can't be with us today, is our construction manager. So here's our request for proposal form given to us by NASA that basically describes the task at hand. NASA would like us to create a Mars lander that can safely deliver 2 pilots to the surface of Mars. The Mars lander's performance will be demonstrated during video recorded test on launch day, and the Mars lander shall be reusable. Our contractor requirement form from NASA demonstrates includes that the Mars lander demonstration vehicle shall survive the impact of a 12-foot drop, and the Mars lander demonstration vehicle shall protect 2 eggs from the damage. The final product should be reusable. The vehicle must hold 2 eggs at once, and the vehicle must endure 2 trial runs.
These are our engineering drawings of our final chosen design. On the left, we have the side view. In the middle, we have the front view. And on the right, we have cross sections. And next slide. This is our list of purchased materials. We were provided tape and scissors for free. We bought 1 pool noodle for $5, 1 square foot of bubble wrap for $2, 4 plastic grocery bags for $1, 10 rubber bands for 50 cents, and 3 cotton balls for $1.50. We're also able to request a special salvage material, which were straws for $2. We did not make any changes to our original materials purchase list in our final design. Next slide. This labeled image illustrates all of the materials that we acquired to build the Mars lander. Next slide. Here's our construction plan. First, we cut off about 1 foot of pool noodle. Then we opened a section of pool noodle by cutting lengthwise on one side and scored the inside of the pool noodle with scissors to loosen it. Then we placed the pilots inside to act as spacers surrounding the pilots with cotton balls and plugging the ends with plastic bags. Then we cut off about 8 to 9 inches and taped the bottom of the other pool noodle to the original fuselage. Then we folded 1 square foot of bubble wrap to fit over the exposed eggs and secured them in with rubber bands. Then we took 2 plastic bags and used rubber bands to secure them to both sides of the noodle lander. Next slide.
For the most part, we didn't make any changes to our original construction plan during the final build. The main thing we did was just add some plastic bags as parachutes to the top and put a little section of noodle for the bottom. We were able to secure the parachutes with rubber bands since we didn't have string or something, but that worked well because it was easy to get on and off. A challenge that arose during the construction was that we weren't sure how to fit the eggs into the lander properly because our original was just a hole in the head. The egg wouldn't fit in the hole. So we were able to solve that by cutting it open and scoring the bottom to keep it open. All in all, our team was able to successfully work together during the construction phase of this project. Next slide. These are the images of our lander before the test. So yeah, next slide. So these are the results from the test runs 1 and 2. They took place at the College of Engineering A building stairs on October 14th, and the lander was dropped from a height of 11.3 feet. When we first measured the vehicle, the length came out to about 30.5 centimeters. Width was 12.7 and height was almost 48.26 centimeters, including the bags. The test engineer, Tyler, was able to load the pilots in 30.63 seconds. The first run was successful. Both pilots survived, and the test engineer was able to unload the pilots in 6.71 seconds. The second run took place, and our Tyler was able to load them in about 24.86 seconds. After the second run was successful, he unloaded them in 5.83 seconds, and the vehicle stayed together, so its dimensions didn't change. So here are the videos from test one. Yeah, so we did fine.
Oops.
So these images show our pilots and the lander after the tests. So as you can see, the pilots are fine. The lander was not hurt at all.
Okay, so in conclusion, our team was able to create a successful final product, and as a team, we were able to work successfully in all areas of this project and design. During the design phase, we were able to quickly throw out ideas and develop a simple design that we were able to add to during the redesign phase. For the most part, we stuck to our chosen design with the addition of 2 parachutes in the final product, and in our group's opinion, we believe that the parachutes are ultimately what contributed to the lander's success, as the parachutes were able to help soften the lander's landing. Our vehicle results clearly show how successful our product was, and we were able to design the lander in a way that a test engineer, who in this case was Tyler, was able to quickly unload and reload the pilots into the fuselage. And we were able to create a product that was able to keep the eggs intact from a 12-foot drop. During the assembly phase of our project, we were able to all work successfully as a team, and we were able to quickly redesign our lander, and were able to put the final product together in less than 25 minutes. All in all, I would say our group was extremely successful during this project.